All right. So let me explain what I'm trying to do. So I have a Raspberry Pi 3 here, and I'm trying to, well, what I'm doing right now is I'm just going to uh, set it up with my phone's hotspot and SSH into it. So that's what I'm doing here. That's just going to take a second. It's not good yet. At some point, this Raspberry Pi will boot up. There we go. Ugh. I have no idea why it needs to download the server every time. It's probably not supposed to do that. All right, so I had this, which just runs on an RP2040, and it uses the Pico SDK, so I'm using like these things, these functions. But now I need GPIO and also SPI communication to work. Um, there's a bunch of stuff Copilot generated for me just for SPI, and it does work. I'll explain a little more. It's like there's an asterisk there. We're also using like a Linux time library, time.h. I don't know. Um, so this is opening up the SPI device, and then we get a file descriptor. Um, and here's what's weird. If we put our buffers to just read from the who am I register, um, let's just add this right here, that number. What am I doing? Um, in Yeah, and then that'll just be SPI and I. So the first one's always going to be 0. And then let's just continue there. All right. Uh, Oh, yeah, this is weird. I have to do this sometimes. Sudo systemctl stop pig pod dot system, I guess. There we go. In 080. That's actually not supposed to do that last I checked. Because this, oh, never mind. This is not who am I. Who am I is 75. Um, yeah. So the second one is 47, which is the reset value for the who am I register. So spy communication works in that case. And also I've separately tested that the GPIO works. Um, thing is, yeah, thing is, if we try to do all 13 of these reads, 13 is the initial one and then the 12. Let's just add a thing here. So k excel config, whoop, not that one, k excel data 0. So this is supposed to do a bulk read of all 12 registers, which is the 6 measurements stored as 16-bit numbers. And this is just the last bit appended, the last bit set, which makes it a read command. Anyway, this doesn't work. Yeah, 32, which is 1F. Actually, no, it's not. Oh, because we needed to that. Anyway, um, it turns out to is this how this works? Okay. All right. Comp run. Sweet. Comp and run. Um, yeah, anyway, the beginning is, damn, it's still not 31. That is 1F. It was actually doing a different number before. The second number should be should be 80 hex. Huh. Anyway, the point is that it's not working. So what I'm actually gonna do is I have my logic analyzer over here. I'm just gonna sniff these IO ports and see what's happening. This will almost certainly tell me the answer. It's just annoying to set up. So we have those 4 channels. We're actually gonna need a fifth one just for the IMU device that has a interrupt pin, which tells you when the data buffers are ready. Slowly connecting all of these things. That was ground. All right, this first one, it's going to be chip select. That's an easy one. The next one, oh crap. Jesus Christ. This one the wrong way. Oh. Uh, damn. We have the first 2 items here. Okay. I put that second one on wrong. This first one will go with ground. This brown one will go to clock. I get an aneurysm. I need to use my tweezers and just bend this back into place. All right. Yeah, so we gotta play it. Calm and run. Oh, it's just not connected to my Raspberry Pi anymore. Probably shorted it or something. Literally, that might have been what I did. It's probably, yep, sudo systemctl stop pig pod. All right, so I should now be seeing things. Doesn't seem to be showing up at the other end. I have a serial analyzer here. Hmm. I should do something different. Huh. Suddenly doesn't want to work. Oh, because that's not right. This needs to be like that. Okay. 47. Run that. Right, D3 is apparently set at SDI data in. That's actually orange is the one. It's backward, but it doesn't matter. All right, so that works perfectly. So what happens when so now it's reading who am I and it's reading who am I and then also come on this one. So we just gotta go to who am I? And it should read the register bank selection. Oh, and then nothing else, because, okay. So that's a bad example. Um, well, actually, let's just, okay, weird. Oh, it starts at 17, I guess. Yes, so C one F is acceleration data. Okay, let's just see if it's sending the correct bulk message. It'll be that one, I think. So hmm. All right, so you should be reading the correct stuff, but it looks like they just have the same number for every single one. So we figured that out at least. Um, we need another variable so we can look at the timing of the interrupt pin. That's the important one because I think my SPY library is working fine, but my GPIO library is not, which is ironic. There we go. Yeah, so it's just staying down the entire time. Which isn't supposed to happen. So let me gonna take the actual pin out of the IMU device. So this will be coming straight from the this is coming straight from the actual interrupt pin. Seems like it's just not working. There's always a bad sign. Low, it's supposed to be low active. Yeah, so this works. It's just not actually doing anything. Which is bad. The fact that it's not going high after the read. Very concerning. So this one worked. Just gonna see what we did here. Seems like what we did is fine. We're gonna continue here instead. Wait until it's low. It's ridiculous. Okay, well we know the SPY is working. The interrupt pin is just completely whack. Here's the thing, it should be working. The only reason it stays down is if it never thinks data is being read. Which might happen if these settings are not set up correctly. Clock is low when active, high when inactive. This thing needs to be specific, doesn't it? It's picky. There's a timing thing here somewhere. There we go. 4-wire spine mode. See, the clock has to be up while idle. You know what? This is totally it. Let's edit this again. Clock, high when inactive, and it is data is valid on clock. Not leading edge, but it's actually the trailing edge. It's valid. So there we go. Well, now it's bizarre why it even worked with the 75 one. 75? That actually must have been like a hell of a coincidence. Okay, well, we'll just try it. The mode is an integer. Alright, how do I... Fix? Okay. We'll ask Copilot about this one. What am I using? Big copy paste. I want it to be cpol and cfa. Cpol equals 1 and cfa equals 1. Spy mode 3. To mode. Yeah, we don't want Spy mode 0, we want spy mode 3. Alright, this should work. Running, save, run. We have an idle eye clock. So now it's correct. Data is valid on the leading edge. Actually, what did I have it on the this one? C phase 1, C pole 1. Yeah, so you know, maybe I missed a bunch of registers though, so I have to like restart my chip. It's a hassle. It's probably worth it. Damn. The fact that it's the same means nothing. I bet my IMU works with both settings. The idle state of the clock actually changed too. Yeah, so something's wrong here. Let's read some other registers. We want some registers with some nice reset values, like drive config 0, 0, 08, 0. Oh, reset value. Oh, interesting. So it just never gets updated? This doesn't do some weird shit at the beginning, does it? Yeah, well, okay, that kind of looks like weird shit. And now what we have to do is we have to do this and then run it, fill it, see what happens. Looks clean. All right, what's after all this data? I just want to find some fun reset values. 1000000004 00000. I think that's good enough. So main 1 so address 2D, OX2D, and there's 13 of them, so we'll just read them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the eighth one is the 04. So this should return the 10 and then the 04. Interesting. Wow, this is really bizarre. Writing is done like that. AD, that would be 2D, which is the address I asked for. And that should have returned what I said. All of these should be readable. Alright, how do I reset this? I'm just gonna unplug and replug it in. There we go. Alright, this should be replugged in. And it does the exact same thing. This is really bizarre. Valid on the leading edge. What am I doing wrong? Select goes down too. And the who am I buffer works. Guess we can try drive config. Reset value of 5. It's 13. This is bank 0. So it's the 13. Register. Which is fitting. Everything is going to be 2 now. We're just reading from one thing. Alright, so it is 5. And what if we read from 13 objects? It doesn't magically break, does it? No, it doesn't. In fact, we have 5 and then 1, 2, 1, 2. That one's supposed to be 0, but it's temperature data, which I guess is being updated and turned into 0. Oh, I think I lost one of them. It's pretty much the same anyway. We have the 5. Although that doesn't really look like a 5. It's a 5 and then an 8. Okay. Now it just stays like that. Okay, let's try something. I'm gonna display analog. There we go. So we're having some wigglage, a really small amount. It's just capacitance from the read pin. Looks like. Okay. Not useful, apparently. And it never goes higher than that. And this pin does have down means it needs to be accessed. All right, let me just, don't know if the computer will be able to handle this. Three-volt chip select. This is actually a little bit interesting. Go up to here to see if we can record it. Okay, I guess it's fine. Looks like everything is pretty good. And the interrupt still did not show any sign of changing. Did I just short my Raspberry Pi? No, still there. So this is just staying at 3 volts, the power. This problem is impossible to fix. What's interesting is I don't know, it feels like I just bricked my chip. Okay, so we do have a low impedance. Oh, it's supposed to be a pull up. Jesus Christ, it's always something stupid like that. Alright. Dude, there's no way. This is probably it. What, up? We didn't need the pull up before. Didn't I have that in here? Apparently needed. New initialization. Spy initialization. Where is it? There we go. Disable pulls. Oh, RX pin. Pull up. There it is. Jesus Christ. There's no way. Why is this broken? Oh, because it's finally reading it, isn't it? It's finally reading this thing. The pin is 1. Which it is because it's being pulled up. Here we go. It should work. Okay, we can just do that for now. Now it'll just go whenever the hell it wants. Let's just make it like that. Yeah, that should work. Okay. Yeah, that doesn't help anyone actually. So we've got to move this back to OX1F. There's no way. This is supposed to be a pull-up. Oh, it's not plugged in, that's why. These silly little mistakes. Well, now it's a pull up. Is that way too strong of a pull up? Goodness. Okay, let's just try this. 3,000 millivolts. Oh, what's this? Okay. So this thing just doesn't do anything then. Hmm. Changing this, change that. So the GPIO does work. It's just not strong enough, where it's never signaling ready. What the hell could I have forgotten? What frequency is this? 1 megahertz by bus. Didn't I change this to be slower? No. Oh, it's like, okay. This is the correct speed. Oh, what is this? Oh, it's just a chip select. So dumb. Even after reading 1F. Doesn't want to work. I read all the data. Mostly miso, blue, green. Blue is attached to that third pin, which is data in. Yeah. No, the SPY signal is working. The chip just isn't offloading its data. The chip is probably bad, but I'd have to confirm it with. Alright, so my plan for next time is I'm going to confirm that this chip still works. I'm going to confirm that this chip still works with the old code. This one right here for the Pico SDK. Because if it doesn't work, that means my chip is broken and I'm gonna have to buy a new one for $30, which is fun.